Hi guys, this is Varun Sharma and welcome to Intellectual India. In this video, I am going to talk about the Mangalyaan or Mars orbiter mission, which is launched by ISRO. So let's move to the introduction part. Introduction. The Mars orbiter mission is ISRO's first interplanetary mission, and it is also known as Mangalyaan, or in short, MOM. It was a complete success, and now it is currently working properly and sending lots of data over Mars to India. Planning for MOM. How the Mars orbiter mission has been planned. In 23 November 2008, ISRO first revealed that he is going to plan for the Mangalyaan, and the successful launch of the Chandrayaan-1 in 2010 gave the Mars an opportunity to reach on Mangalyaan. So that's why he has planned to launch Mangalyaan. This project was approved by the Prime Minister on 3 August 2012, and the total cost of this mission was 454 crores, and that is very much less than the NASA's cost, which is 4,700 crores. And ISRO is also known for the cheapest and best satellites manufacturing organizations. Let's move to the team. What are the teams of Mangalyaan? So team of Mangalyaan, there are lots of scientists who are involved, and they are proud of our country, who has made our country proud, and they have developed the Mangalyaan mission. Some of them are K. Radhakrishnan, Malaswamy Andwari, and S. Radhakrishnan. You can see lots of names. Momnita Dutt, B.S. Kirna, V. Kesav Raju. There are several scientists who has planned lots give their best for the Mangalyaan and successfully launched it. So let's move to the rocket. Which rocket is used? For launching Mangalyaan, rocket uses PSLV C-25. It stands for Polar Satellite Launch Vehicle. PSLV stands for Polar Satellite Launch Vehicle, and it was made under the governance of Dr. APJ Abdul Kalam. This rocket was made to launch remote sensing satellites, IRS in short, and some small geo satellites in geostationary transfer orbit. And PSLV has 4 stages by which it is capable of lifting a satellite from the ground to the space. Let's move. What are the internal parts of the PSLV? Internal parts of the PSLV rockets are, you can see the parts, like there are 4 thrusters which are only used to lift up the PSLV rocket from the ground, and that they have used their whole energy, the whole fuel, in lifting PSLV from the ground only. And you can see lots of parts: equipment bay, Venturi interstage, solid motors, interstage, and there is a small part. This is where the satellites are kept. It is called a payload firing, and that is the only place this satellite is only fitted there, and the whole rocket is used to just lift this satellite to space. Next, move to the design. How the design? Mangalyaan Mars was about 1,337.772 kgs, and there are lots of equipment which are very common and installed in every satellite. There are buses, power, propulsion, altitude and orbital control systems, and antennas. Buses are basically that they are used to transfer the information from one place to another place, and there is the spacecraft's bus is modified I-1K structured rocket and propulsion system, and this is the advanced version of the buses used in Chandrayaan-1. Moving to the power uses the power generated by the Mangalyaan is three solar panels, and it produces the power of 840 watts, which is very much high. And propulsion, a liquid fuel engine which is with a thrust of 440 newtons. It contains a rocket boost engines which provide a thrust of 440 newtons to move it from one place to another. Next, to altitude and orbit controlling system. This altitude and orbit controlling system is basically used to control the orbits of the particular satellites, and you can see that maneuvering system that includes the electronic with MAR31750 processor and 2 solar sensors. You can see some of the parts are 2 solar sensors, solar panel sensors, coarse analog sun sensors, 4 reaction wheels, and the primary propulsion system. And basically the communication system, which are antennas. There are 3 types of antennas there, which is low gain antenna, medium gain antenna, and high gain antenna. The communications are handled by 230 watt TWTA and 2 coherent transponders, and there it is used 3 types of antenna, which I've already told you, that is low gain antenna, medium gain antenna and high gain antenna. You can see an image of antennas. These 3 of them are of same types, but they have lots of different frequencies, like one is high, one is low and one is medium. So communication, in the communication part, there are 3 types of antennas, which is low gain antenna, medium gain antenna and high gain antenna, and they have different frequencies, but structure is same, as you can see in the present the picture. And moving to the objective, what are the main objectives of this mission? Why ISRO launched this mission? So there are 2 types of objectives, that is mission objective and scientific objectives. Mission objectives are more than scientific objectives. Mission objectives means what the mission is, why the reason that ISRO launched that mission. That is for to develop more technology, so that ISRO can launch more interplanetary mission to different planets like Mars, Venus and other planets in our solar system. And it is to explore Mars, how the Mars looks like. There are the 2 main motto of this mission, and you can see there are lots of some of the small mottos. They are not that much major, but both of them are major. And the scientific objectives are very important for them, because they are the only reason but why this Mangalyaan was launched, to see how the Mars looks like, what are the surface of the Mars, what are the atmospheres, how the upper atmosphere looks like, and what are the gases which are present in it. And this is the whole type mission objectives. Scientific objectives, you can see that exploration of Mars surface features by studying and morphology, topography and mineralogy. Study different types of minerals and their layers of atmosphere, what are the gases present, what are the things which is present in this atmosphere, and study constitution of Martian atmosphere, including methane, carbon dioxide, and using remote sensing techniques. There are lots of instruments which is installed in the Mangalyaan to sense these types of structures, these types of things. Moving to the instruments, what are the instruments installed in it? They are Mars color camera, LEMF alpha photometer, thermal imaging spectrometer, and Mars exospheric neutral composition analyzer. And last one is methane sensor of Mars. There are all the instruments which is helping to look after the Mars, why the Mars is the main functions, to do the functions why the Mangalyaan is launched. And there Mars color camera, you can see by the name that it is used to give the color of the Mars, which color is Mars is actually. And that last one is methane sensor of Mars, it is used for the sensing methane, the amount of methane which is present on Mars. This is the launch of Mangalyaan, how the PSLV rocket has launched Mangalyaan mission, Mars orbiter mission. So let's see the video. So next we are going to see the steps. How are the steps that Mangalyaan has been launched? So you can see that Mars has started from here, Mangalyaan launched from here, and it revolves first around the Earth only. And after some years, some weeks, it has been provided a thrust that it lead to the moving to the Mangalyaan Mars orbit. That you can see that after something like that, it has given a torque which is responsible for moving the Mangalyaan from its Earth's orbit to the Mangalyaan orbit towards Mangalyaan. Next step is moving toward the Mangalyaan. You can see that the pink one color is the Mangalyaan, and the green one is Mars. And how you can see how the Mangalyaan and Mars came in the orbit of the Mars. So moving to the third step, that is how the Mangalyaan revolves around the Mars. you can see the revolving structure of the Mars, Mangalyaan around the Mars, and you can see that most of the satellites, all of the satellites, most of them are revolving on different types of planets are like this, but some of them are having different types of structures. So that's all for today, and I would like to tell you that India was the Mars mission was the first interplanetary mission which was successful, and with that it was the world's first mission which was able to launch successful and move to the Mars successfully in its first attempt. So I would like to tell you that to be proud of India and proud of the scientists and to be proud of India. Thanks.